This is a clear example of the inverse variation. X varies inversely or inversely with y. See it here. And the first two numbers are stated. Will be used to establish a constant, which you have, and create a relationship, which we've done here. And likewise, from B question, they said, find x when y is 0.25. 0.25. Or we're able to change 0.25 to 1/4. I think I've showed you somewhere there that 0.25 is still the same as 25%, which is 25 over 100, which is 1/4 if you take it to the lowest term. So we change the division and we get our final answer there. The same applies to when x is given as 1.6. We go back to the formula from here. We put 1.6 here, equal to 42 over y, then we cross multiply the expression. You see how we made 1.6 8 over 5. Actually, it was supposed to be like this: 1.6 equal to 16 over 10, which is 8 over 5. That's why this 1.6 became 8 over 5. Now, that's for inverse variation. And in some other instances, I told you, like some other cases where they could give you, let me give you another similar example, but we'll be using different things entirely. Here, example 2. They could tell you, for instance, P varies inversely as the square root of Q in this order. Yes, they could give you like that. Jamford specifically do this every other day. So here, when they will not give you the first two statements, which will come like when P equal to, let's use 12, Q equal to 25. Okay. Now, they will not ask you, find Q when P equal to, let's use 15 for a start. Ready? Now, let's see how we solve this question. Solution. Do not be afraid. Just go the normal usual way. P varies inversely as the square root of Q. That's the word here. Sometimes, and one other thing, if they address this in words, do not be afraid. It will come straight like this, like P varies inversely as Q. P varies inversely as Q. Not P varies directly as 1/Q. Don't mistake them and don't mix them up. So P varies inversely as Q. We need to get rid of this variation sign by establishing what? A constant. P equals to K all over root Q. Remember, where K is our constant. So what do? We use the first two numbers given. P is 12. K is root what? All over K all over root 25 because Q is 25. Change this Q, substitute 25 there. So this will give us 12 equals to K all over 5. All over 1. If we cross multiply the expression, K equals to 5 times 12. So K equals to 60. 5 times 12 should give us 60. Now if 5 times 12 is 60, we need to establish a relationship. So the relationship will take this loop. Or if you want to call the formula, call it. Whether they tell you to establish relationship or not, I've told you, compulsorily after getting your constant, go back into that what? Variation and establish a constant. P equals to what? 60 all over root Q. Okay. So this is what we have for relationship. Then we can answer the question. What are we going to have here? Say find Q when P is 15. So when P equals to 15, we go to the equation. P equals to 60 all over root Q. P will give us 15 equals to 60 all over root Q. What do? We cross multiply the expression or the equation precisely. So 15 times Q, root Q will give us 15 root Q equals to 60 plus 60 times 1. So what we do here is to divide both sides by what? 15. We want to have 15 root Q divided by 15 equals to 60 divided by 15. And 15, we take out 15 to give us root Q equals to what? 4. That's 60 divided by 15 is 4. Now, when you get to this point, try your indices. Have you watched the indices class? Please go for that video. Now here, this is assumed to be Q take this root power, make it a fractional power. Remember, the fourth law, I think the sixth law, the fractional laws of indices states that x raised to the power 1 over a equals to the a root of what? X. All values taken from new general mass. Those symbols there. Are you there? So now if you have q raised to the power 1 over 2, which is given as this, to get rid of that 1 over 2, you need to multiply both sides, the index, with the multiplicative inverse. What's the multiplicative inverse here? 2. So multiply inverse, index. That index means power, precisely, index, by multiplicative inverse. What do you mean by that multiplicative inverse? To get the multiplicative inverse of 1 over 2, the multiplicative inverse is 2. So that when you times them, they become 1. They tell you what's the multiplicative inverse of 2 over 3. It is 3 over 2. If you times them, they'll give you 1. So for that reason, you're going to have this q raised to the power 1 over 2 all squared equals to 4 raised to the power of 2 also, that you square both sides. The right word is, people tell you to square both sides. Is that clear? If you're squaring both sides, it's still the same thing you're doing. Remember that the law states that power can multiply also. So this will cancel this. So q will equal to 4 times 4, 16. So this is the answer to q. If you come from here and you decide to square both sides, you're very okay. You're very okay. Is that clear? Well, there are some instances this q might be having maybe probably root q raised to the power of 3. You can't square both sides alone like that, because this written q will be equals to 3 over 2. This is it here. So in this situation, why I said you should use multiplicative inverse is when you have a situation like this equals to what? 4. Then I guess you should do what? Do this. Q 3 over 2 raised to the power 3 over 2 times 2 over 3 equals to 4 raised to the power of 2 all over 3. That way you'll be on the safe side. Is that clear? Alright, so square both sides. It's allowed. When you say square both sides, you're good. You're good. That means you already know what to do there. So bringing multiplicative inverse is just trying to explain it in depth, so that you actually understand, okay, this is what they actually did. So this, as far as I can tell you, on inverse variation, anything you come across that has to do with x, where you have this variation sign and you have 1 all over something, that's inverse variation. Is that clear? Rule 1, establish a constant. Rule 2, from your constant, create a relationship. From your relationship, then you can solve any other question there.